The mass of large sac is normally distributed with a mean of 55 and a variance of 9. And the mass for small sacs is also normally distributed with a mean of 27 and a variance of 2.5 squared. Now, some of them are loaded onto a board. The maximum load is 340 kilograms. We need to find the probability that the boats can carry safely 3 randomly chosen large sacs and 6 randomly chosen small sacs. So the total weight for 3 large sacs and 6 small sacs must be less than 340. Let's say L represents the mass of large sacs, then L follows a normal distribution with a mean of 55 and a variance of 9. And S represents small sacs, so S follows a normal distribution with a mean of 27 and 2.5 squares. For part A here, the total load is 3 large and 6 small. We let X to be the total load. So this is given by 3 large. You have 1, 2, and 3 large, the sum of 3 large sacs, and the sum of 3 small ones as well. So you have S sub 1, S sub 2, you add up to S sub 6. And we need to find the probability that X is less than 340. The expected value of X is the sum of the expected value of all these random variables. There are 3 L here, so we have expected value of L1 plus expected value of L2 plus the expected value of L3. And then we have the expected value of S1 up to the expected value of S6. Since all these expected value of L1, L2, L3 are the same, and there are 3 of them, we have 3 times 55, and there are 6 small ones, so we have 6 times 27. Then the expected value of X is 327. The variance of X is the variance of L1 plus the variance of L2 plus the variance of L3, and then you have the variance of S1 until the variance of S6. Since there are 3 of them and their variance is 9, then we have 3 times 9 plus 6 of them, and you have 2.5 squared. And that should give us a value of 64.5. Then X follows a normal distribution with a mean of 327 and a variance of 64.5. Since all these random variables are independent, as these are randomly chosen, then X follows a normal distribution as well. To find the probability that X is less than 340, we have to standardize, and you use the Z-score formula, 340 minus the mean divided by the standard deviation. So we have to take the square root of 64.5. And this gives us a value of 1.619. We can get this value directly from the standard normal table, which is 0.947. For part B, we need to find the probability that a the mass of a randomly chosen large set is greater than the total mass of two small sets. So from here, we need to find the probability that L is greater than S1 plus S2. This will give you the total mass of two small sets. And we can rearrange this so that we can write this as L minus S sub 1 minus S sub 2 greater than 0. Let's say we denote this as Y. Since these are all randomly chosen, the random variables are independent, Y follows the normal distribution, and we need to find the mean and the variance of Y. The mean of Y is the mean of L minus the mean of S1 minus the mean of S2. We have 55 minus 27 minus 27, which is 1. So we know that the mean is 1. Then the variance of Y here is the variance of L plus the variance of S plus the variance of S. And that will give us 9 plus 2.5 squared plus 2.5 squared, which is 21.5. So this is 21.5, which is the variance. The probability that we need to find is the probability that Y is greater than 0. We standardize this and we have probability Z greater than 0 minus 1 over square root of 21.5. And we have probability that Z is greater than negative 0.216. Probability Z greater than negative 0.216 from the standard normal distribution, we have negative 0.216. We need this area. But the normal distribution that is given to us is a left hill distribution. So instead, we look for 0.216 and we find this area instead. That is given by 0.586. So the required answer is 0.586.